The idea with this webinar is to talk about a little bit about what the mixed model business strategy is, but then try to do a little forecasting. These have been crazy times in good ways and maybe not so good ways. And so we want to take a look at what maybe is coming up this year in 2025 as best as I can figure it. Now this is a huge subject, right? It's like a tsunami. So we're just kind of skimming the surface here with maybe some highlights that I can identify. We could be talking all day about all the things going on. And there are people that actually do that for a living, just trying to keep track of all the changes that are happening. And I don't have time to do that, but let's just see how far we get. So basically the agenda for this webinar, let's talk about the backstory related to mixed modeling and business strategy. So we want to set a strong foundation for what it is we're talking about here, because we're not talking about everything in the world. So how do the changes that we see coming in 2025 apply to those domains? Lean manufacturing or mixed model manufacturing or continuous improvement, and this idea of business strategy. So we'll define some terms, and then we'll go through the top changes that, or developments, maybe not changes, but advancements or developments that we see happening in 2025 this year. It's now, as I'm recording this, it's January 17th, so first month of the year. And then I'd like to conclude this webinar with what should a lean specialist do related to those changes. So you may not be a lean specialist, but maybe you're a manager with responsibility for lean efforts. I assume that our audience is kind of involved in the world of lean manufacturing or Six Sigma or continuous improvement. Okay, so let me get started. The backstory. So TPS is the Toyota production system. DFT is something you may not be familiar with, but it's a abbreviation for demand flow technology. And that's how I got my start in the world of lean, learning about and applying something called DFT. Now, DFT is really, one way to define it is it's an Americanized version of the Toyota production system, where we don't use a lot of Japanese terms, but a lot of overlap with the Toyota production system. But another way of thinking about DFT is that it's lean industrial engineering focused. So a lot of the great developments that have happened in the Toyota production system or in lean more generally over the last, say, 20 years or so, from the point of view of DFT are great, love it, important, but DFT is focused on the foundational kind of disciplines, which is really, this was a question that was asked to Taiichi Ohno at the Toyota system. What is the Toyota production system? And he said, ha, 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 he laughed good-naturedly. He said, this is just really Toyota's version of industrial engineering. So that's kind of what DFT is all about. And by the way, in the 90s, 80s and 90s, a lot of companies adopted DFT as their gateway, their introduction to what we now call lean. This was before lean was lean, before the term lean was even used. Now, the other thing to mention by way of the backstory or introduction is that DFT was marketed, let's say, as a total business strategy. So what does that mean? It means that it's not just for the factory, it's not just for a silo kind of application, but the DFT, this is the way it was sold anyway, the DFT approach should be applied to every process, every department in a company. And therefore we called it a total business strategy. Business strategy would be, how do we compete in the marketplace? What's our method or plan for competing in the marketplace? DFT should be applied to everything, to everyone, every department, front office, back office, factory, purchasing, engineering, etc. Everyone's involved. Now, I mentioned the General Electric video. You can find this on YouTube. If you do a Google search for General Electric video, Jack Welch, DFT, there's a video that we used when I was working with DFT. We used incessantly as a promotion for DFT, where Jack Welch is standing up in front of the annual meeting and saying, DFT is a total business strategy and it will apply to every department at General Electric. So you can see at that time, at that moment, he was strongly embracing DFT at General Electric. That lasted about a year or two. And then someone got his ear about Six Sigma, and General Electric kind of made a shift to a focus on Six Sigma. But I'm sure there are elements that still remain. There are other companies that adopted DFT at that time. I'm saying probably the early 90s, and they're still at it. One of the ones you'll recognize is John Deere. If you kind of look under the hood at how John Deere runs its factories and runs its company, it's very much a DFT-based model, even today. So we have lean today, we have Six Sigma, we have MMM, mixed model manufacturing is our current term for essentially what used to be DFT, but mixed model manufacturing also incorporates a lot of elements of lean, what we now call lean. And that is our Leonardo Group, my company's kind of a trademark. It's not trademarked, but it's our brand, mixed model manufacturing. So just quick review, a strategy is a plan of action. So how are we going to compete in the marketplace? How are we going to deliver what the customer wants quickly with high quality and reasonable price? And many companies have adopted lean manufacturing as their basic strategies. David went to a DFT class. Yeah, I might have taught it. Okay, so now business strategy as it applies from the Toyota production system point of view, I just want to point out something interesting to you, that if you go onto the internet, Google, and you look for a definition of lean, it's going to say something probably about eliminating waste. There's a focus for eliminating waste. And what I want to point out to you, and I've talked about this in previous webinars, so forgive me if you've heard this before, but basically Taiichi Ohno said in an interview after he'd retired from Toyota, he said, when I was with Toyota, I was very concerned about competition from Americans and from Europeans with our Japanese efforts, right? And I wanted to help our fellow Japanese companies, but I didn't want to kind of like give away the store with what we were doing inside Toyota. So I came up with this story that I thought that Westerners, Americans, Europeans could buy, but it really was intended to, it was a red herring. It was intended to lead them off the track, right? To confuse them, to baffle them in a sense. And that story was that lean was all about eliminating waste. And pretty much it made sense to them. Also, I'd like to use a lot of Japanese terms. That confused them as well. So Kanban, Kaizen, blah, blah, blah. So, but what he said in this interview was that my real objective at Toyota was to implement what he called the river system. In other words, flow manufacturing or flow. And eliminating waste and all these other aspects were contributors to achieving optimum flow. But that was really our main focus. And this is a little excerpt from this book. You can find this the whole interview in this book called Profitability with No Boundaries. I think I got it on Amazon. So that was kind of an eye-opener that really a lot of companies here in the U.S. and other places have been implementing lean, but somehow the next Toyota is hard to find. Now, no doubt, right? Eliminating waste is a valuable thing to do, but if it distracts you from a focus on reducing the total manufacturing cycle time and building this kind of totally integrated flow system, then you're going to get some benefits, but you're really not going to be at Toyota level of effectiveness. So I thought that was a really interesting insight. So what can we do to improve flow within our manufacturing processes or within our company? Doesn't have to be manufacturing, within our service industry, if you will, too. Well, the 7 ways, clearly we know about that as a lean specialist. So these are the things we typically do. And we want to aspire to 0 defects. If we have bad quality or quality issues, that's a problem, right? From a customer point of view or from a flow point of view. If the flow has to reach a certain point and then go backwards because we have defects or rework, that's a problem. So that's part of the Toyota production system philosophy. Implement pull in production and supply chain. So pull systems like Kanban and other methods, and from a supply chain point of view, pulling from outside suppliers. That's really a big deal within the Toyota production system and lean in general. And then we have this element of lean, which they call respect for people. But it's really about human development and building your workforce and creating longevity in your management structure through a really carefully considered, carefully designed process of developing people so they can become better problem solvers, so they can be more effective and take on more responsibility within a company. And Toyota, I think, does a really excellent job of that. Now, one thing related to this whole effort is that if we don't have enough business, enough volume, then it's still going to be a struggle, even if we do all these other things right. And so there's something called Wright's Law, a gentleman named Wright. Wright's Law says that basically when you double production, you actually reduce cost per unit by some factor. And that factor can vary. But basically, if you can achieve higher volumes, then your product cost per unit is going to go down. Another way of describing Wright's Law is the learning curve effect. So if you don't have enough volume, you're still probably going to be challenged from a competitive point of view, from a cost point of view. Your margins are going to be less. So it's important, I think, overall to think also in terms of sales, right, and achieving enough production volume to get to that critical level. All right. So total business strategy, again, simple definition. We're talking about a strategy that impacts every part of the company, including all the support organizations or front office processes in a company, and ideally extends beyond the factory walls. So you're never going to achieve really good inventory turnover until you have outside suppliers integrated into this via milk runs or via frequent deliveries in small quantities, even if it's an overseas supplier. The total business strategy then will have an impact on sales, not just on cost, but impact on sales, improving sales. Has to be led from the top. So one of the questions you might ask yourself is, in our company, can the C-suite leaders actually teach lean subjects, not just give lip service to it? We're not implying that they're not supportive, but can they actually teach these subjects if they had to? We're not asking them to become teachers, but if they had to, can they teach things like 5S? Can they teach things like flow? And if they can't, it probably means they don't understand it, because I think it was, at least it was attributed to Einstein, to Albert Einstein. He said, if you can't explain something that can be understood by your grandmother, you probably don't understand it yourself. So that's one quick test of your C-suite leaders. And then, within the company, is everyone actually trained? And is there a succession plan in place for your management team? We're currently working with a company who laid off a bunch of people during the COVID pandemic, including people that had been trained in lean for years, and now they're in the process of having to rebuild. And maybe that's one of the reasons why Toyota, they can afford to do this, but they really don't lay people off, permanent employees off during downturns. Okay, so when we say dominate your market through lean or through mixed model manufacturing, is this am I just being hyperbolic? Is this just marketing stuff? Well, I can just point out a couple examples. Certainly Toyota is an example. I just did a quick check from 2024 last year, and Toyota was still #1 unit sales in the world. I don't know if they'll always be there. They've got some stiff competition, but anyway, they're still #1 in unit sales. The Lexus line and the Toyota brand is not far behind. #1 most reliable, #1 market share. This is TMH, Toyota Material Handling, the fork truck division. #1 market share for 24 years straight. And the other company, which we actually have worked with a lot, is John Deere. As I mentioned, they've adopted more of a DFT strategy, more Americanized strategy or version of lean. but number one sales in farm equipment worldwide in 2024. Number one in tractor sales, 2024, US and the world. And they've, like Toyota, they've grown their market share year upon year on a worldwide basis. So at least two good examples. Maybe those were, the best examples I could find, but they do exist. So just to wrap this up, this introduction, the mixed model manufacturing methodology is a method, right? So it's not just a philosophy, it's an actual strategy that you can apply with a step-by-step, roadmap. And so this is just an example of the total high-level roadmap for mixed model line design. But there is a process that we teach, and there's a process that you follow, right, to get the desired result, which is a high-performing, high-quality, high-productivity mixed model line that can produce a variety of products on the same assembly line without losing productivity, without losing quality. And we have the same kind of roadmap for the material delivery system. So the two need to work together. You have the workflow that needs to be properly designed, and we have the material delivery system that delivers what is needed, the rights of material delivery at the right time, the right part, the right quantity, etc. So there is an actual science to this as well that you can follow. Now, time out for a quick commercial. If you want to learn, if you're not familiar with mixed model manufacturing or you want to brush up, you can take a course with us, with Leonardo Group. And this course is hosted at Toyota. So Toyota trusts us enough to be able to teach this class inside their factory in Columbus, Indiana. The next one's February 18th through the 20th, 3 days. So you get inside the mothership and you learn about, in this case, line design, so workflow design. And it's taught by either myself or Gerard Leone, my partner, and walks you through the whole process, plus a whole bunch of, not a whole bunch, I have 2 factory tours, Q&A sessions with the Toyota people. So it's really, it could be a life-changing experience. This kind of experience was really career-changing for me as well, in terms of, seeing how things are done, seeing how things should be done. So it's really, really fantastic. So if you want to find out more about that, just go to this link here, leandesignstudio.com/mixed model line design. Okay. Here's an example. This is a picture. This was just taken recently. It's an example of the size of the class we have. So relatively small group, and pictures are taken. And if you can't make it to the Toyota class, we do have a backup. We have a plan B. We do have something called the Lean Design Studio. So again, go to leandesignstudio.com, where we offer the same training that you get at Toyota, minus the Toyota tours, minus the Toyota magic and fairy dust that you get by being in the Toyota factory. But basically the same content is available with a lot of other things, including simulation modeling software and a lot of other goodies in the Lean Design Studio. So check that out as well. All right, let's get going. Here's the meat of this webinar. What to expect in 2025. So here are 8 things that we can expect to continue on, to strengthen. I'm not saying these are totally new, although some of them are actually, but here's what we can expect to see, the 8 maybe the most important things related to our profession, right? Lean professionals, continuous improvement professionals. So number 1, integration of, well, I'm going to go through in more detail. Let's just do a quick read through. Integration of smart manufacturing technologies. That's already happening, but that's going to happen some more. Emphasis on sustainable manufacturing processes. Now, the ones I put in red are the ones we're going to explore in more detail, but they're all important. So sustainable manufacturing processes, clearly important. Expansion of automation and artificial intelligence. That one's huge. That one, you can't miss that one, right? Adoption of advanced additive manufacturing, again, like 3D printing and those kind of things. We're not going to get into that. I don't know that much about it. It's interesting stuff, but I'm not really qualified, but that continues to advance. Shift towards decentralized manufacturing methods. By decentralized, we mean moving manufacturing closer to where the customers are. And we'll talk about that in a little bit. Focus on workforce upskilling. again, I already mentioned a case where we're working with a company that had a need to upskill because of all the layoffs they did. But this is a continual need, and there are some improvements made in how we go about doing that. Integration of edge computing. So edge computing means bringing the processing closer to the user, similar to decentralized manufacturing. So as opposed to relying on the cloud, we're moving that processing power, software, tools closer to where we're actually using them. There are a number of reasons why we might want to do that. Security is one of them. And then finally, strengthening cybersecurity measures. Again, this is going to be more and more important as the power for evildoers to use these same tools to mess with us increases. And again, this is already happening. So we're going to go through the ones that I've marked in red here in more detail one by one. And again, my apologies, we're kind of skimming the surface. I couldn't help that because there's just so much. But I just tried to pick out some nuggets. I hope you'll enjoy hearing about this, but I don't want you to think that this is all there is to say about these subjects. Far from it. Okay, integration of smart manufacturing technologies. So what we're talking about here is AI, sensors, Internet of Things kind of approach, and then these technologies that are coming up pretty fast. And one of the biggest ones by far, I would say, is humanoid robots, humanoid robotics. Now, this may not come to fruition completely in 2025, but it is a big deal. You probably, if you've been following these developments, you know that this week there's a convention in, I think it's in Las Vegas. Yeah, Las Vegas, the CES 2025 show. And apparently robotics is a big deal at the show, getting a lot of attention. I even saw a video of Jensen Huang, I think his name is, the CEO of NVIDIA. And he came out on stage and he had like 12 or 15 different models of robots out there on the stage with them. It looked amazing. So tons of information out there on these developments. And what they were talking about was the cost going way down compared to, even just a few years ago. I think this $1 a day was an aspirational number that they put in, kind of like clickbait. But the actual projected cost for some of these humanoid robots that can do actual work, right, that have extremely capable hands, is more in the range. I mean, now in the range of $5, $10 a day, or maybe an hour. I don't know, something pretty affordable. So a plethora of options that are being developed right now. This particular YouTube article that I found was top 15 humanoid robots that will be for sale in this year, 2025. So again, this isn't theory. This is actually happening. The other thing that is getting some press is Elon Musk and Tesla. They're developing their robots. And what Musk was quoted as saying is that humanoid robots will be the biggest product in history, more than the car, right? More than the automobile, more than any product you can think of. The biggest product in history is what he said. So in this quote, a statement that hints at a future where robots will outnumber humans. So Musk suggested a world where the ratio could be 5 to 1, meaning 30 billion autonomous humanoid robots could one day, again, not 2025, could one day be operating. So this ball is already rolling. What he said, and he tends to be overly optimistic, right, in terms of his timeframes. But he said something about Tesla plans to produce between 50 and 100,000 units of Optimus, their model, right, their robot, in 2026, so year after this one. But I also saw that this year they plan to have several thousand Optimus robots working within the Tesla plants. Not a few, several thousand working within the plants. So, and then ultimately by 2027, so that's very fast, 500,000 to 1 million Optimus robots. So again, he tends to exaggerate, the speed at which these will happen, but still, it's not way off in the future sometime. It is very soon. Yeah, someone mentioned the cost, but the range seems to be quite wide, but the goal for a lot of them, the Chinese manufacturers as well as the Americans, seems to be to get these robots into the range of the cost of a car, like a small car. 20,000, 25,000. I saw some 40,000. But if we're talking about robots replacing people, that's still quite affordable in terms of doing work. All right, so that's the biggest one. So this year, 2025, we can expect to start seeing these a lot more than we had. And Tesla's not the only one using them, obviously. A lot of automotive, I think BMW has robots working, and who knows who else, right? So a lot of folks, we're going to see an explosion of this, but more at an introductory stage in 2025. Not just doing specialized things, but these are general purpose. The whole point of humanoid robots is they can do things that humans currently do, so that the workspaces that we currently have are designed for humans. Therefore, a humanoid robot can fit right in and kind of take over. All right, next thing, edge computing. This is going to blow your mind. The moving computing closer to the users, right, who are using it. And why would you want to do that? Well, here's some benefits of what they're calling edge computing. So you've got processing power that's local, so you're not depending on some faraway, server farm or some faraway, resource that you're depending on over the web. It's happening locally. So there's probably some speed advantage to that, but also some security, as they mentioned here. So you've got a huge amount of power that's available to you locally. Running AI models is something that a lot of companies are interested in and a lot of companies are doing, but there would be no latency lag if you have it locally, and also there would be no security risk if it's not connected to the internet. And so especially aerospace and defense companies are very concerned about this, about the security aspects, and you can have local AI resources, brains available to you running locally without relying on going over the internet and exposing that information. So there's a lot of interest in this happening, but here's the thing that's kind of mind-blowing. At this conference a few days ago, and I pulled this off the web, off of YouTube, but at the conference going on, in Las Vegas, again, NVIDIA announced this desktop computer that's about the size of a Mac Mini, or about the size of one of those VHS tapes. So small, right? It can sit on your desk, and you can see the specs here. It's got 4 terabytes of solid state storage, connectivity, Wi-Fi, Bluetooth, USB. And then here's the thing that I can't quite get my mind around. It's got the NVIDIA Blackwell GPU, graphics processing unit, that runs at 1 petaflop. That's a processing speed. And so I had to look up, okay, what is a petaflop? And I put the definition on here for you. It said a petaflop is a measure of computational performance equivalent to 1 quadrillion floating point operations per second. A quadrillion can be expressed as 1 million billion, 1 million billion, which is equivalent of, well, you can see it here, lots of zeros. So that's the processing speed of this Mac Mini size device. And the 2 amazing things in addition are this: it's planned to be available within a few months. I think early summer, I think is what they said. He showed an example of it, but available for purchasing or delivery early summer, late spring, early summer, something like that. And the cost, $3,000 is what they're projecting. I remember when I bought my first IBM PC. I'm really dating myself because I bought, those of you that are of a certain age like mine will remember that when the IBM PC came out, They also had a luggable, I don't want to call it portable, luggable version called PC Portable. And I bought one of those. And this was about 1985, I think. And it weighed about 20 kilos, right? 44 pounds, something like that. And it was kind of like lugging a sewing machine around, maybe heavier. And I paid, this is in 1985 dollars, I paid $3,500 for it. I guess I was excited, right? I was willing to make that investment. I think it was worth it. Now, in today's dollars, that's over $10,000. So now we can get this essentially unbelievably powerful supercomputer for $3,000. Right? Now, why would we want to have one of these things? Because this little box is going to run the biggest AI models that are available fast, right? And you can communicate it without going over the web. It's got Wi-Fi, Bluetooth. Communicate with this thing locally. So quite mind blowing. I'm kind of tempted to get one, right, when they become available. All right, so that's edge computing. Now shift towards decentralized manufacturing models. We've seen this happen a lot. Actually, this is kind of a lean thing of moving, or maybe a Toyota thing, of moving production close to where the customers are. So as opposed to having a big factory somewhere, and then you export all over the world from that factory, you're moving production close to where the customers are. And that's happening, globally, and that's also happening, within a country, where they'll have smaller factories that are closer to reduce transportation time, maybe to even get better contact communication with the customers. You're closer to them. So they're definitely, and I think this was encouraged by the COVID pandemic. There's definitely a movement, which is sometimes called onshoring. That's bringing manufacturing back to the home country, or nearshoring, meaning moving it from someplace that's far away and moving it closer, although not necessarily within the home country. And the example we have that I'm sure you're all aware of is Mexico has become a destination for products that used to be made, in Asia or far away. Mexico has become a huge, manufacturing powerhouse. A few years ago, I was in Monterrey, and when you travel around Monterrey, or I drove from Monterrey to Saltillo, the neighboring city, it reminded me of China. There are huge football stadium sized factories along the sides of the roads, and then housing developments for workers, and lots of trucks on the road. It was quite amazing. So that would be an example of nearshoring. But certainly onshoring is bringing work back to here. I think that the Biden administration, with some of their, the CHIPS Act, the Inflation Reduction Act, put a lot of funding into bringing these things back, especially things that were considered, security risks, like the fact that we weren't making all the semiconductors that we needed to, on our own soil in the U.S. So the CHIPS Act is promoting, manufacture of semiconductors here in the U.S. So that is happening in a pretty big way. I think, if I remember right, this is just from memory, that manufacturing in the U.S. Over the last few years has added something like 800,000 jobs in manufacturing. A lot of it related to this, onshoring or nearshoring. And this may or may not continue, depending on, the support that it gets, from the government and other places. But I think it will. And for us as lean people, that's been a good thing, right? It's been a lot of work, a lot of new plants going up, greenfield sites, expanding existing brownfield sites, both here and then close by in Canada and Mexico. In fact, there's a guy named Peter Zain, really interesting. He's a kind of a geopolitical analyst, futurologist. And he said that in the future, he envisions North America as being a really like a combined superpower. We don't have to be the same country, as has been suggested, but U.S., Canada, and Mexico as a block, because it's very complementary, especially Mexico and the U.S. relationship, very complementary in terms of wage levels, abilities, where today in Mexico, the manufacturing skill, worker skill level is exceeding by a significant amount, even places like China and a lot of other locations. So he really is bullish on the Canada, U.S., Mexico trading, manufacturing block in the future. Okay, so who's doing this? This is just a quick review. Who's doing this onshoring? What industries? Well, semiconductors, we mentioned that. Automotive, especially Mexico is huge in the automotive realm, including Chinese companies building EV plants in Mexico. A lot. Pharmaceuticals, renewable energy, battery manufacturing's going up a lot. Aerospace and defense has always been kind of centered here, but maybe even more. Consumer electronics, textiles, food and beverage, machinery, and chemical manufacturing. So a lot of industries. This is not a complete list, but these are the top 10 that are bringing work back to the U.S. And no doubt this is going to continue. All right. Next thing, focus on workforce upskilling. So you might have new people that need to be trained. You might have an existing workforce that needs a refresher, right? Needs retraining. So let's talk about a couple things that are happening there. One of the concepts I really love, and we're trying to implement in our own practice, our own training, is called flipping the classroom. So flipping means the old model is the teacher would kind of transfer knowledge from the teacher's brain into the brain of the students, and then the students would be given homework assignments where they're supposed to go off on their own and try to apply these things and do homework exercises or do projects outside of the classroom. That was homework. That's the traditional way. But flipping means exactly that. We're going to flip it. We're going to reverse it so that the basic knowledge, information piece of it, students learn on their own. And the online training tools and animations and all kinds of improvements that have been made in the ability to learn online have improved. So it's easier than it was even just a few years ago. So they'll learn the basics, the information transfer happens on their own. And then within the classroom, that's where the teacher is really needed, right? To, help people hold their hands in terms of applying what they've learned and doing exercises and giving them feedback. So it's a reverse of how things were traditionally done. And I have some data here. Again, this is not a new idea. It just hasn't been applied very much. We're kind of stuck in the mud with how we do our training. But some studies that have done, this one from Vanderbilt University. I actually almost went to Vanderbilt University. I was accepted to Vanderbilt University. I ended up not going there. But anyway, they did a couple studies of students, and what they said here is that the students in a flipped classroom exhibited learning gains 2 standard deviations higher than traditional classroom students. And in a second study, student engagement increased from 45% to 85% simply by flipping the classroom. So this all makes sense to me, right? And it's something I think needs to be done a lot more. In other words, use online training to just get the basic information and then apply it under a human teacher's tutelage or do projects under some guidance. So from a lean point of view, let people learn the lean concepts online and then apply it with them. Spend your time applying it through Kaizen events or through actual exercises. That's how it should work. Now, in terms of online training, we've also introduced something in our online courses, like the Lean Design Studio that I mentioned. So instead of testing knowledge with a multiple choice, true, false kind of, traditional online quizzes, tests, what we've done is we've started to introduce AI in the form of conversations, what we call conversations. So in our latest class on the topic of Obeya, the students will take a lesson block, and then they'll go to this section where the Obeya master is going to engage in a conversation. Now, in the future, this could be audio. Right now, it's text, right? It's like a chat bot. but the Obey a Master will ask them a question. The students will type in their response to the question. And then based on their answer, the Obey a Master will then follow up. So it's quite remarkable to see this in action. So it's literally a conversation where the Obey a Master, meaning the AI, is able to look at what was communicated before by the student and then come up with follow-up questions, follow-up discussion, specifically on the topic that was just learned. So this is kind of mind-blowing to see it. And I think when it's audio, it's going to be even more powerful. Now, the other thing, though, is at the end of this conversation, the Obey a Master, the AI, is going to analyze the conversation against the learning objectives for that lesson. In other words, there were some things that the students should have learned in that lesson. And so the Obey a Master knows what those things are. And based on the conversation, the Obey a Master is going to give you basically a feedback or a report. You were strong, you understood this well, that's great, good job, kudos. This thing, you missed this is important, and maybe do like a re-explanation of the items that were missed. So extremely powerful. We're excited about this. What I would like to see is just basically replacing true, false, multiple choice types of questions with this kind of dynamic AI-based conversation. Right? So 2025 for us is to rework our existing training. So we introduce AI conversations into basically all of our courses. Right, now here's the most important point. I'm looking at boy, we're running short on time. So let's get going. This topic is AI, right? Expansion of automation and artificial intelligence. This is really the big one. So there are things happening currently today with AI. There's a company that we're partnering with. We're getting trained. Actually, this week we had some training sessions with them on how to actually use their tools and hopefully share those with our customers. But the company's called retrocausal.ai. I invite you to check them out. That's their website. Basically they have some, I guess you call it proprietary AI tools that will using cameras. So it's not sensor based, it's camera based, vision based. It will look at work being done and learn that work and document it, and then use that as a guide, for operators. It's kind of like a heads-up display. It doesn't have to be a helmet or a goggles, but it can be a screen monitor. But it monitors the work, and it can be used for training or just for quality. It's like having a hopefully friendly, inspector looking over your shoulder and making sure you're doing this correct. The other tool they have is called the Kaizen Copilot. So Kaizen Copilot will help analyze a process and suggest improvements and create an ergonomic plan and create a process improvement strategy, et cetera, for a particular workstation or process. So extremely powerful. And big advantage is that it's vision-based. So all you need is a laptop, and it's cloud-based. So you need a laptop, a camera, and that's about it. So we're currently getting trained in this, and this is going to be really taking off. It's already taken off, but it's going to be much more known in 2025. The other big deal, though, for 2025 is something called agents. So again, at this conference, Sam Altman, who's the CEO of OpenAI, was interviewed, and what he said flat out is that the biggest advance for AI in 2025 is the introduction of agents. So what is an agent? Well, it's basically a way that AI can actually start taking actions, not just giving you advice, but actually, taking actions within the realm of the digital world. So it's not going to actually be physically manifested. That's the robots that are coming a little bit later. But an agent can do things like book appointments, analyze data dynamically, give you monitor process performance as long as it has the data. So this is going to be, agents is, according to Sam Altman, I guess I believe him, going to be the big deal in 2025. So how would agents be used? Let's click through these fairly quickly. So an AI agent for mixed model line design. So that's what we do, right? That's our kind of our wheelhouse, our specialty. So in this case, an AI agent, assuming that the AI agent has the data, which which at least at this point, retrocausal could help us gather that data, but otherwise it's us, right, gathering the data. But with that data, it can basically do a lot of the line design work that we do as industrial engineers. So line balancing, simulation modeling, testing various scenarios, analyzing changes in mix and volume, testing flexibility of this design, optimizing layouts and space. A lot of these things can be done by agents. So we don't have to give the agents specific instructions every time. We train these agents, and then with the data that's provided, they can actually go and do this work. So that's going to be a big help, I think, for us, hopefully. Not put us out of work, but actually, improve the quality of the work we do. And then the other thing is AI agents for material flow. So the material delivery side of things. Again, mapping material flows, optimizing delivery routes, determining the optimum replenishment method. Should it be Kanban? Should it be sequence delivery? Should it be kitting, etc.? And then actually managing the material delivery system. For example, managing a Kanban system. Toyota has some great software they've developed internally, private, but it does a great job of error-proofing their Kanban system internally at Toyota Material Handling. I mean, quite amazing. But an AI agent could actually do that as well. Monitor usage, monitor when Kanban cards may be misplaced. The key to all of this is getting access to the information. But if they have that, then AI agents can start taking over a lot of the stuff without the need for programming. That's the thing. What Toyota has today is they have a system developed by coding it, right? Coding up a program with if this, then that kind of set of rules. But with the AI agent, you don't. You describe in English how you want it to manage, and then it kind of does it in a black box kind of style. Okay, next, the other things, AI agents. So AI agents for supply chain management. I know we're running short on time, so I want to kind of click through these things reasonably fast. So supply chain management, again, with access to your ERP, MRP system, you can design an agent to dynamically monitor that system and provide all kinds of recommendations in terms of inventory levels, monitor your supplier performance, their on-time delivery, monitor the external market sometimes, etc. So I see really, really huge opportunities here in the realm of supply chain management. Production scheduling, again, the same thing. If the AI has access to your backlog, to your lead times, to your line design performance, then it can create a balanced, sequenced production plan that helps. In other words, what we sometimes call Heijunka. AI can actually be your Heijunka master and create an optimized production plan on a day-to-day basis. Predictive maintenance. So what we're talking about here is not waiting for something to break, but with sensors, or it could be even a non-sensor approach. Maybe the sensor is a microphone. So AI listens to a machine and does essentially a machine learning analysis. And when things change, it can actually raise a flag, right? Something's changed. And so you can actually avoid machine downtime. Or IoT, that's Internet of, what is the T? Forget. Internet of Things. There we go. Internet of Things. Sensors is another way of getting access to that information. Next thing, worker training. So we've touched on some of this already, but there are things that are happening very quickly in the realm of AI video or augmented reality AR systems. So there are going to be huge, huge opportunities, and I see 2025 as being like a watershed year. Where we can say when we look back on it, 2025 was a year when this really started to happen, where we can develop training. It could be training, or it could be actual guidance, right? When someone's actually doing the work. And retrocausal is already working on this. Basically, that's what they do with their assembly Copilot product. So step-by-step instructions, et cetera. So this is happening. So I said C retrocausal AI. This is happening, but it's going to be more and more. Next thing, Kaizen and continuous improvement support. So if you had one of these NVIDIA brains, NVIDIA machines on your desktop with a massive AI model that's been trained in all of your processes, could that be a valuable contributor to your Kaizen efforts? Absolutely, completely. So you basically share information with, with the AI, and you would be, if you've done any AI, exploration in this realm, you are sometimes surprised at what it can come up with. Things that make a lot of sense, but you hadn't thought of yourself. So I would see AI as being like a co-pilot on our Kaizen efforts. You'd always want to run it through ideas, suggestions, problems, brainstorming with, through your AI. Absolutely. Why wouldn't you want to do that? Okay. So I think that that's the best I can do. Sorry about, what's happening in 2025. It's just an awful lot. As I mentioned, there are people on YouTube who've made it their full-time job just to try to keep track of what's going on. Because it's every week, there's this one guy named Matt Wolf who I like. Every week he comes out with his report. It typically publishes it on a Friday. And every week there's something. I mean, there's no week where he says, gee, folks, nothing happened this week. No, it's like unbelievable. So what can go wrong? Let's talk about that for a second. Everything that I've discussed so far seems very positive. But what can go wrong with these efforts? Well, one of the things is societal disruptions when AI starts replacing people, right? Human beings. And I'm not the first to mention that. I mean, it's a big concern across the board. And this is actually happening. There was a company, I think it was a Swedish company. It was a payment processing company that you can read about, but they claim that with an AI agent that we just finished discussing, an AI agent that's basically a customer service agent, they reduced the errors that a human agent would make. They improved customer satisfaction. People liked it better relating to an AI customer service representative. And they eliminated the need for 700 humans in this company. 700. And they claim to have saved $40 or $50 million, something like that, per year. So that sounds great, except, okay, now you have 700 people that have to go find something else. Now, something else to do, right? So if you start expanding that, multiplying that kind of human replacement with agents. Now, remember, agents right now can only work in a kind of a digital realm. They're not going to replace people that do physical activities in the physical world yet. But the same issue is going to come up when humanoid robots start taking over some of this work as well. That's the second bullet point here. So probably not this year, but 2026, 27, 2030, these humanoid robots are going to become more and more intelligent, more and more capable, and a lot cheaper than a human. So this is going to be a big deal that society needs to figure out. If I don't have a job anymore, how do I live? Right? How do I survive? Is the question. And I think in the past, when we've had technology changes, somehow people found other things to do. When people went from farming to the factory because of farming automation, they found factory jobs, et cetera. There always seemed to be, or in the US, we went from manufacturing-based economy to a service-based economy. But people have been saying that this may not be so easy this time to find something else to do. If a humanoid robot can do it faster, better, cheaper than a human, anything can do anything faster, better, or cheaper than what are the options? So universal basic income. There's been a lot of talk about this, but I don't think that has been figured out yet. Now, we could also have economic downturns. For example, the current administration coming in has been talking, at least, about tariffs, about deportations, about taking over other countries, about, and that can lead to lots of issues, right, with inflation. So that's going to put a damper on all of these changes, improvements that we talked about if we're struggling with that. Certainly, it's not clear to me that that people understand that tariffs mean we pay the tariffs. China doesn't. We have a tariff on Chinese products. China doesn't pay it. We pay it, right? So it's a tax, basically. It's first of all a tax on the company that's importing, and then it's a tax on us because that cost gets passed down through us. So I'm not sure all these things have been understood clearly, but we don't know how this is going to roll out yet. And then we could have a fourth thing. What can go wrong? Where we somehow fail to advance technologically. We kind of hit the wall with the ability to improve AI. AI just doesn't get better. And so, we can't say it's fully implemented now, but it's just not improving. People actually have been saying things like that, but I doubt very much that's a big risk, right? That, as far as I can tell, every week it's getting better and more powerful. And all these announcements by NVIDIA and other companies is just still continues to be mind-blowing. So I don't think that's a big risk, but that's something that is worth adding to the list anyway. So what do we do next? What do we do as lean people? Recommendation, and this, by the way, this recommendation came from AI. I asked AI, what should a lean specialist be working on in 2025 to advance their career, right, to improve their job security, et cetera. So I'm going to provide with you, I'll activate it right now, a copy of this presentation. So I don't have to read all this stuff to you, but let me go to Files and I'll turn it on. I'll say Share. Okay, so you can get access to this this presentation and read through some of these things because I think we're running out of time. I want to get done in an hour. So embrace the digital transformation. So again, if you're resisting, you should get into it because it's going to happen. Next one, enhance problem-solving skills. Well, that's always true, isn't it? But you have some tools that are now available to help you with that, to identify the root cause of problems and make sure you're totally mastered on these things like five whys, Ishikawa, et cetera, A3 thinking, et cetera. That's pretty basic. Focus on mixed model manufacturing. Now, I didn't prompt ChatGPT to tell me this. It's kind of a self-serving, isn't it? You might think, since that's what we do. But it said, focus on mixed model manufacturing, increasing product variety and customization demands. So specialists should deepen your expertise with mixed model line design to manage high product mix and variable demands environments. Okay, so good, thank you very much. Unsolicited, but it did. Learn and apply lean-enabled AI tools. Absolutely. So tools like I just mentioned, Assembly Copilot, Kaizen Copilot from Retrocausal, and more generally, learning how to use agents, learning how to create agents. And it's already available today, and learn how to use those. That's going to be absolutely huge. Transformational. Stay educated and certified. Again, thank you very much, ChatGPT. We've been trying to promote that, and I'll just add to the offerings here the line design workshop. I think you can see that. So if you want to go to find out more about this workshop coming up very soon, it's coming up in a month at Toyota. You can get a lot more information here. Just if you click on this link, you'll go to the information page.